In light of the COVID-19 pandemic and the vaccination efforts that have come underway, it's worth asking, while we can make vaccines, how do we cure a virus? Most people will tell you that because of their characteristics, viruses simply cannot be cured. But I'm here to tell you that in fact there is a virus we can cure, the Hepatitis C virus, or HCV. HCV is one of the viruses that can cause hepatitis, inflammation of the liver. Patients with hepatitis can develop jaundice, poor appetite, vomiting, and fatigue in the acute stages. However, chronic hepatitis is very dangerous and can lead to irreversible conditions like liver failure and liver cancer. According to the most recent figures, over 70 million people worldwide are chronically infected with HCV, and most people infected with it go on to develop chronic hepatitis. This virus causes 400,000 deaths per year globally, and prior to COVID-19, HCV was the leading infectious killer disease in the United States. Despite these figures, the most popular reference seems to be from an episode of Rick and Morty. So I thought, why not present HCV in something even more exciting than Rick and Morty? A poem. Ladies and gentlemen, I present to you the story of HCV. 1989, it was discovered, the virus known as hepatitis C. Imagine one having to suffer after getting a major surgery. In fact, getting any surgery or any emergency blood transfusion could have caused this hepatitis C to be your unfortunate conclusion. The researchers were awarded the Nobel Prize for discovery of HCV and its malfunction, and the ways they used to characterize like an antibody-antigen reaction. These discoveries were breakthroughs, paving the way for screening tests and treatment, where it took less than 30 years to come to, a cure for HCV, an amazing achievement. Let's see how the cure, Direct Acting Antivirals, works. For HCV to replicate, it needs three critical enzymes: NS3-NS4A protease, NS5B polymerase, and NS5A protein. But that's a mouthful and it doesn't go with my rhyme, so I'll just call them Thing 1, Thing 2, and Thing 3. HCV enters the liver cell to find a host ribosome. It then goes on to use this machine, not forgetting its RNA genome, to go ahead and make a polyprotein. Thing 1 makes mature proteins by cleaving this polyprotein. Enter our first antiviral. This DAA, or Thing 1 inhibitor, stops this guillotine and disrupts the viral life spiral. As viruses make more of their genome to place into their newly made virus morphology, HCV uses Thing 2, an RNA-dependent RNA polymerase, spitting on the grave of the central dogma of biology. We'll split back with our second DAAs. These inhibit Thing 2 by means of two ways. We got MPIs as one of the inhibitors. As Thing 2 is making RNA post-translation, they enter Thing 2 as unwelcome visitors. The MPIs fool Thing 2 and cause chain termination. Now we turn to NNPIs, and I know again with a unique name and creation. They go from behind Thing 2, bind to a non-active site, and result in negative allosteric modulation. Thing 3 is the NS5A protein, a mysterious shaft, presumably helping in assembly and replication, but we know HCV needs it, so a DAA is attacked, and voila, disruption of viral generation. From discovery to the cure of HCV, we should be in awe. All these viruses were discovered before, yet they have no cure. The fact that happened in fewer than 3 decades is incredible. COVID, HIV, and other infectious ones, the cure lies in wait. HCV stories and DAAs give hope for continued breakthroughs.